Okay, so we've been really moving now on the idea of sine and cosine and using those trig functions and how they operate in various situations. We've looked at the unit circle, we looked at radians and degrees and all that stuff. So we're going to kind of combine some of that stuff that we've done in the last few days and turn it into some graphs of these functions. And so what we're going to do first is we're going to look at the graph of y equals cosine of t. All right. T is standing for, it's just a variable, but we're going to use radian measures for this. All right, and then I'm going to remind you of those radian measures before we get started here and how they relate to the unit circle. So if you remember, 0 radians is the same as 0 degrees, so that would be starting out to the right there. Pi over 2 is the 90-degree position. Pi is 180. 3 pi over 2 is 270. And then if I came all the way back around, that would be 2 pi radians. So each of these really has a counterpart, 90 degrees, 180 degrees, and so on. So what we're going to do now is we're going to remember that, first of all, this is a unit circle. The radius is 1. And so, at any given point, I can be no further than 1 unit in any given direction from the center. All right, so that said, we're going to start to map out what cosine or y equals cosine of t would look like. So t is my input, t is my degree measure in this case. So we're going to start at 0. All right, so when my degree measure is 0, cosine, the x value of that point, is going to be 1. So this would be where I start in my cosine graph. By the time I get to pi over 2, I've gone from here all the way up to here. Now again, cosine, remember, is my x-coordinate. So what is the x-coordinate of this point up here? That is 0. So at pi over 2, or 90 degrees, I'm down to 0. All right, now let's go to the next significant point. At pi, or 180 degrees, now my x-coordinate is -1. At 3 pi over 2, my x-coordinate is back to 0. And at 2 pi, my x-coordinate is back to 1. Then if I were to go another 90 degrees, or another pi over 2, I'd be back to 0. And one more pi over 2 would have me back at -1. All right, so right now, it kind of looks like we just have, some straight pieces there. But if you remember, this is going around a circle, so it's going to go, in this case, the x-coordinate is going to decrease slowly at first because I'm not going left very much initially. And then as I get over here, I'm going left a lot, and then not as much anymore as I get around there. So it's going to be a curve. It's going to be kind of a wave. Another way to kind of check yourself a little bit here is at right here at pi over 4, which would be right in the middle there. I don't know if you remember this, but that's about or approximately 0.7. So if this would be 0.5, this would be 0.75. So it's right about there at pi over 4. And that should help you to notice that it's not a straight line down here. All right, so I'm going to make my curve. It's going to curve down like this. And then it's going to kind of reverse itself. All right, so now at this point, I'm going around the circle. I got to my x-coordinate of 0. Now I'm going back to my x-coordinate of -1. Now I'm going to go back towards an x-coordinate of 0. And then back from 0 to an x-coordinate of 1. Back down to 0, curve back, and so on. I keep going that way. And in fact, if I did negative angles, then this would be curving back this direction as well. So that's what the graph of cosine looks like. Now, what's really important for you to remember or to have in your memory is this section right here, the first period of cosine. All right, if you can get that particular piece in your brain really well, then that'll help a lot as you move forward. So I'm just going to highlight that piece a little bit differently here. I'm going to make it a little bit darker. All right, this is the first period of y equals cosine of t. And then from there, it really just kind of keeps repeating itself. So I'm just going to leave that as it is for now, and then we are going to go back and do y equals sine of t, and then we'll kind of talk about these things in conjunction with each other. So just like cosine, if I'm doing y equals sine of t, I'm dealing with my unit circle. The radius is 1, and I'm moving around it. So now I'm going to look at my y-coordinate. All right, so when t is 0, when I'm at 0 radians, my y-coordinate for this point is also 0. When I get to pi over 2, my y-coordinate for that point is 1. And then when I get to pi, I'm back to a y-coordinate of 0. Down here I have a y-coordinate of -1. Back to 0, back to +1, back to 0. All right. This is going to look very, very similar to the graph of cosine. Some of you may even notice that it really just looks like it's a horizontal shift of cosine, and it is. All right, so that'll keep going that direction. This one would keep kind of going this direction. There we go. And that's what the graph of sine looks like. Again, you want to have a really good memory of this piece right here, the first period of sine. First period of sine, it starts at 0, 0, and then goes up from there and then back down. All right, so similarities. Well, first of all, these two have the same period, which makes sense. It goes all the way around the circle in 2 pi radians, no matter whether we're talking about the x-coordinate or the y-coordinate. It's going to have this wave to it, again, because it's going around a circle, which is a uniformly curved component or curved shape. And it's just a little bit shifted because when we're doing cosine, we're doing the x-coordinate, we're starting at the highest possible x-coordinate because we're all the way out here to the right, and then as I increase my angle measures, I'm moving left first, and then I'm coming back right. So I start at a very high positive, and then I go lower and lower and lower from there, then I go into the negatives, and then I come back out into the positives. Okay, starting high, going lower, getting into the negatives, coming out of the negatives, and getting back positive again. This one, again, as my point is going around and around in the circle, I'm going to start at 0, which is midway between my lowest y value and my highest y value. And if I'm going in a positive angle measure, then I'm going to increase first. So 0 is increasing first, and then the y value is decreasing, decreasing some more, and then it's increasing again. And it would continue that pattern over and over and over again. All right, so that's what those two graphs by themselves look like. Now, what we're going to do with that, I mean, obviously we're going to talk about that in class a little bit, but one of the things we're going to do in class is we are going to try to graph some functions that aren't just cosine or just sine. So we're going to take this one, for instance, y equals 2 sine of t minus 1. And I'm going to have you pause this in just a little bit once I give you some instructions, but I just want you to think about this. What is going to happen to my sine graph when I throw the 2 and the -1 in there? What's it going to do to the graph? So think about that. and then unpause this when you're ready to continue. All right, so what you should notice is that the 2 should be a vertical stretch. Okay, it's going to stretch it 2 times as tall as it would have been. And the -1 should be a shift down. So what would that look like? All right, well, let's look at the sine graph. The sine graph starts at 0, 0. All right, starts at 0, 0. So I'm going to just do some pencil marks here. I'm going to start at 0, 0. Then at pi over 2, usually it goes up to 1. See, I've marked this a little bit differently because I'm going to need some room. Then it comes down to 0, down to -1, up to 0, up to +1, and back down. Okay, so I have kind of my pattern here. I know it's kind of hard to see most of my dots, but I think you get the picture. All right, what will the 2 do? The 2 will stretch it. So now my points would be up here. It would still be here at 0, 0, but I'd be up here at 2 now. Back to 0. Now to -2, to 0, to +2, and then back down to 0. And then the last thing is I would -1. So I'd move everything or shift everything down 1. And so if I shift all my points down 1, this point is now going to be here. This point will be here. This point will be here. This point will be here. And so on all the way around. And here is my graph. Again, I want to make it curved. That's going to go down there, and I'll have to catch it there, back up. Not doing as great with my curves on this one, and back down. Okay, so you can see it looks a lot like this one, and that's because I scaled it down. So really, if I were to base it on this graph, it would be a lot stretchier. So this would go way up tall, way down low, way up tall. That's kind of how it would look in comparison. But I want you to notice something. 2 aspects. Remember amplitude and midline? All right, if you look at this, let's go back to the original graph of sine. It's the amplitude. The amplitude is 1. It goes from the midline. The amplitude goes up 1 or down 1 to get to the highest or lowest point. All right, so the amplitude for that is 1. What's the midline? Well, the midline is 0. So amplitude is 1. Midline is y equals 0. And guess what? That's the same thing for cosine of t. Amplitude is 1. The midline is y equals 0. All right, let's go to this one. This one's really interesting. The midline, let's start there. Midline is right here. That would be y equals -1. And the amplitude, okay, so from the midline to the top point would be 1, 2 units. All right, now, do you see those 2 numbers anywhere in our formula? Amplitude, midline. I'm going to leave it like that till you come in and see me in class tomorrow. Bye.